A few weeks ago, I was getting ready to record a video on the pulleys on the top of a drill press and how you can use them to your advantage to either increase torque or increase speed of the drill bit. And I noticed that my video was flickering. And I thought, instead of doing this video on pulleys of a drill press, let's talk about sampling rates and why my video is flickering. So I don't know if you'll be able to see the flickering of the video here, but I'm going to go frame by frame and show you how each frame is either light or dark, and then we'll get into the physics of why that is. Okay, so here you can see light, then dark, light, dark, light, dark. So the first thing I did was build a light sensor so that I could detect it, and here I'm drawing out the schematic for it. So you can see it's a 5 volt DC source with a resistor and then a light dependent transistor, and there is where I measure the voltage out of this circuit, and the resistance is 50 kilo ohms. Here the circuit is set up running with my oscilloscope, and I actually have two traces on the oscilloscope screen. The little one is the light circuit, and then the second one is monitoring the AC household voltage, and so it's measuring the 120 volts AC out of the wall. So you can see that the light frequency is actually higher. It's at 120 Hertz, and the reason why that is because LEDs are diodes, and a diode only allows current to flow in one direction and not the other. So here is how I'm showing the behavior of a diode. It carries current in the positive direction, but not in the negative direction. And so you would have this half sine wave, and the frequency of that would be 60 Hertz. And the frequency you can tell by measuring between the two peaks, and it would be 16.6 milliseconds. And if you divide 1 by 16.6 milliseconds, you get 60 Hertz. Now the light that I'm getting out of the LED lights in my garage are producing a 120 Hertz frequency. And the reason why that is because engineers have figured out how to arrange the diodes in such a way that they pass current all the time, and they do that with a bridge rectifier. So here I'm drawing a circuit, and I will show you how a bridge rectifier is set up and how it creates the 120 Hertz frequency that we're seeing. So you arrange 4 diodes in this way, and then what it allows is the AC current to flow current on both the positive and negative going wave. And it creates this waveform that looks like this. And then if you measure in between the peaks, you get 8.3 milliseconds, and 1 over 8.3 milliseconds is 120 Hertz, even though we still have a 60 Hertz source. Now, the reason why these details are important is because my camera was sampling at 240 Hertz, and so I'm going to draw a waveform now that shows how I was getting a light sample and then a dark sample. You can see that with my 120 Hertz light source, if I was sampling at 240 Hertz, you could see how I would get a light and then a dark sample. And that just happens to be the way the camera was sampling. If I had started recording the camera at a different time, the samples might have lined up so that there wasn't any flickering. But I think that might be hard to do. I have set up a light detector here, and that's right there. And so this light detector, so what it is it's a detector, and then it's set up as a voltage divider with these resistors. And so when it detects light, the light detector conducts more, and so the voltage goes down. And when there's less light, the voltage goes up.
And so I'm going to get rid of this channel here. So you can see this is the light detector channel right there. And just me moving around and casting a shadow on the light detector, you can see it move around. And so I know that it's a light detector because if I turn off the lights, we'll see that the voltage will go all the way up and be it'll be a constant voltage versus this alternating voltage that we're seeing. Now the reason why we see the alternating voltage is because the power into my house is alternating current, or AC, and so that causes the lights to flicker as well. And these LED lights, they're actually set up bridge rectified, and so you actually see the frequency here is 120 hertz for the peak and valleys, versus the regular AC that we have coming into our house is running at 60 hertz. And I actually have a second probe here set up to measure the AC voltage, and we can see that that's this much slower waveform here, and I have the voltage division at 50 volts, so we can see that that's measuring, let's see, so if this is our center, about 170 volts peak, positive and negative. And then when you do the RS calculation, that turns into 120 volts. So that's the 120 AC that we normally get when we plug into an outlet. So that's this right here. Now when you rectify that, that gives you this, you can think of, you have this top waveform and then the bottom waveform, and you actually flip those so that they are all positive. And that's what would give us this twice as fast frequency of 120 hertz for the light detector. Now the reason why the video flickers is because this is actually the lights getting dimmer and then brighter again, and then dimmer and then brighter again. And we can't really see it as people because we don't see things that are that fast. But cameras see that because the shutter time is a very small window, and if it happens to line up with this dark period, then it will see that as a dimming environment. And so that's why when you take slow motion video where your camera is sampling faster, you can get these effects where the video goes dimmer. Anyway, it was just a cool example of AC waveform, and I just thought, hey, I could build a light detector and actually prove this out, that that's what's going on. And here it is. Hey, you guys like my videos? Subscribe. I'll make more. Bye.